In this video, we're going to graph this rational function and give all pertinent information concerning the graph. So the information we want are the vertical and the horizontal asymptotes, the x and the y intercepts. And then once we get that information, we'll use what I call the zeros method. And I'm using the zeros of the numerator and the zeros of the denominator. Put those on a graph or a line. And I create some intervals, and we look at the sign, whether the graph is above or below in each of those intervals, and we do the graph. So we'll start with the vertical asymptotes. So here we go. The vertical asymptotes come from values that make the denominator 0, but not the numerator. So let's look at the denominator, the factors here. So x plus 1, it's going to be 0 when x is negative 1, so that'll make that denominator 0. Product of any number with 0 is going to be 0. Now for the second factor, that factor is 0 at 2. 2 minus 2 is 0. You square it, you still get 0. So the two numbers that make the denominator 0, in this case, are negative 1 and 2. Just make sure those don't make the numerator 0, because that means we'd have a common factor with the numerator and denominator. You always want your rational function to be in lowest terms. And you can check that. You plug in negative 1 for x in the numerator, you're not going to get 0. Put a 2 in there for x, you're not going to get 0. So I can conclude that the equations of the vertical asymptotes are going to be x equal to negative 1 and x equal to 2. And now for the horizontal asymptote, that's going to depend on the degree. If the degree of the numerator is less than the degree of the denominator, then y equals 0 will be your horizontal asymptote, always, which represents the x-axis. Now, if the degree of the numerator is the same as the degree of the denominator, then you take the coefficient of the lead term in the numerator over the coefficient of the lead term in the denominator and set it equal to y, and that's going to give you the horizontal. You can only have one horizontal asymptote. You might not have any in some of these functions. You might have an oblique or slanted asymptote, or you might have a horizontal. In this case, we have a horizontal, because if we look at the degree of the numerator, in this case, so if this is x times x, if you just look at the factors, what would be the highest degree term if you multiply this out? You don't have to multiply it out. Just look at what the lead term would be. So I've got an x here and an x here. That'll give me an x squared. And this factor, the third factor here has an x squared. So if I were to multiply these out, I'm only concerned about the lead term, the highest degree term. That would be x to the 4th. In the denominator, I got an x plus 1 squared and x minus 2 squared. So from the first expression, I would get an x squared. From the second one, I would get an x squared. So the highest degree term I can see then would be x to the 4th. And the coefficient here would be 1. The coefficient here would be 1. 1 over 1 is 1. So I get 1. So the horizontal asymptote is y equal to 1. I point out to you right now that the graph will never cross the vertical asymptotes, because that's where the graph is undefined. Those could generate zeros. That's why you have asymptotes. But it may cross the horizontal. Most of the time, if it crosses, it'll cross once, and then it won't cross again. Okay, let's look at the x-intercepts. The x-intercepts will come from values where the y is 0. So it's all we have to do. The g is, this is your y. So if y is 0, this side would be 0. What value of x over here would generate a 0? So in other words, if y is 0, what value of the numerator, what value of x would make the numerator 0? Well, you can see here 1 minus 1 is 0. 3 minus 3 is 0. This factor here is never 0 because you have an x squared and a plus here. So in this case, the x-intercepts would be 1, 0, and 3, 0. Now, for the y-intercept is found by replacing the x by 0. So in other words, if I let x equal to 0, plug it into that function there, put a 0 where the x is, what value do I get for y? Well, let's try it. 0 there is minus 1, 0 there is minus 3, so minus 1 times the minus 3 is 3. And then a 0 there, x squared. 0 squared is 0, and then I get 4/3 by 4/3 there. So I replace the x by 0. In the numerator, I get 3 times 4/3. 3's cancel out, and I get 4 for the numerator. What do I get in the denominator? Well, 0 there will give me 1 squared is 1. 0 there is -2. You square it, you get 4. 1 times 4 is 4. Those divide out. I get 1. So this is 1. So now I have main information. Asymptotes, x equal -1, x equal 2 are the vertical, y equal 1 is the horizontal. X-intercepts are 1, 0, and 3, 0, and the y-intercept is 0, 0, 1. And then I'll just delete these here, and there you have it again, just to make it clear. X equal -1, x equal 2 are the vertical ones, asymptotes, y equal 1, the horizontal, y 0, 3, 0, the x-intercept, and 0, 1 is the y-intercept. So now, like I said, I'm going to, on a number line, I'm going to plot the zeros of the numerator and the zeros of the denominator. Okay, so the zeros of the numerator were 1 and 3. You can see there, 1, 0, 3, 0. And the zeros of the denominator were where the function was undefined, was at -1 and 2. Go to the next one here. And here we have it. So I've already drawn the vertical asymptote. So from 0, 0, I go 1, 2, x equal 2. This is 1 vertical asymptote. There in red. And then to the left, I go 1 unit over x equal -1. That's this one. And then what we'll do here, the graph then passes through 1, 0. And I put that there. Passes through that point. That's an x-intercept, and it passes through 3, 0. That's this one right here. And then we have a y-intercept at 0, 1. That's this one right here. Notice this particular one is on the horizontal asymptote. So this is a situation where the graph does cross the horizontal, but the graph is not going to cross the vertical asymptotes. So now on the number line, what I want to do next is determine the sign of the graph. So you look here, the graph passes through this point right here, 3, 0, and then you have a horizontal y equal 1 there. So you would assume the graph goes up this way, and you would assume between this point 2 and 3, because you have a vertical there, it's going to come down this way. But let's check it out with the number. So to the right of 3, I'm going to pick 4. And I want to determine the sign of the function. If I get a positive number, the graph is above the x-axis. If I get a negative number, it's below. Because we already assume it's going to be positive, because just from the common sense here. But let's check it out. So let's pick a number to the right of 3. You can pick any, this is infinity over here. So that's a big interval. And this is negative infinity over here. So you have to stay to the right of 3. So you can pick up 1,000 over here, but we want to stay close to 3. So let's pick 4. Let's put a 4 in the numerator. What do we get? Notice the denominator, as long as we don't get a 0. We don't want a 0. So 4 plus 1 squared, 4 minus 2, and then you have a squared. The denominator is always going to be positive. So we don't have to worry about the denominator, because of the 2 squares there in each factor. This is always going to be positive. So all we want to know is, what is the sign of the numerator? So up here, 4 minus 1 is positive, 4 minus 3 is positive, and x squared plus this particular factor is always going to be positive, because you have the square there and you're adding a positive number. So here it's a positive. This is positive. Okay. So we know in this interval to the right of 3, the graph is above the x-axis. So now what does it do between 2 and 3? So between 2 and 3, let's pick 2.5. Okay, we want to stay between 2 and 3, so we pick anything you want. 2 1/3. You can use decimals, 2.1, 2.2. But we'll try, we just say 2.5. We know the denominator is going to be positive because of the squares in both of those factors. So here, 2.5 minus 1, that's a positive. 2.5 minus 3, this will be negative, and of course the third factor is always positive, so I have positive times a negative times a positive, and here it's going to be negative. So with that information, then we know that the graph from 3 to the right, it goes up like that. It approaches that horizontal line, equal 1. Between 2 and 3, it's negative, so it's coming down. It's using common sense. You have a vertical, so you assume it's going to approach it. Get close to it, but never cross. Okay. And then between 1 and 2, what does the graph do? Well, we notice it passes. We know it passes to this point here, 1, 0, and then between 1 and 2, we have the vertical this way, so we assume it's going to go this way, like this. But let's check it out. So between 1 and 2, let's pick 1.5. So again, the denominator is positive, so 1.5 minus 1, that's a positive number. 1.5 minus 3, this is a negative. This one's always positive because of the square and the plus sign there. So positive times negative is negative, so I know that the graph is coming down here. So it's coming down like this, approaching the vertical. So notice the graph approaches this asymptote of x equal 2 from the right and from the left. Now, what does the graph do between this point over here of -1 and say 1? See, we know it passes through that point, so common sense would just say that it goes up like that. So let's check it. Let's check it between it's a large interval there, -1 and 1. We can pick 1/2 just to double check here. The denominator is always positive, so let's pick in here 1/2. So 1/2 minus 1 is negative. 1/2 minus 3, that's negative. This one's always positive over here, so negative times the negative is a positive, and then times the positive, so we know that it's going up. And we can test other values, but this is just going to go up like that. The graph looks like that. So we got the interval then from -1 to 1. Now we're looking at, okay, what happens to the left of -1? That's the vertical asymptote of x equal -1. So let's plug in a number over here. So we need a number less than -1. Let's try -2. That's to the left. So it's going to take care of all this area over here to the left in this interval here. So the denominator is positive. So let's say -2 and -1. That's negative. -2 and -3. That's negative. This is going to be positive. So negative times a negative is positive, and times a positive here, that's a positive. So over here it's positive, and this was positive here, and this was negative here. So that means the graph has to stay above the x-axis. And so what can happen? Well, the only thing that can happen then is that, okay, it's in this area right here. We have a vertical and horizontal, so common sense then would simply suggest that the graph looks something like this. Approaches, and this one again approaches the horizontal, approaches the vertical here, and that's what your graph looks like. Thanks for watching. We'll see you next time.